My dear students, welcome back to our channel. In this video, I will be explaining the MCA second semester subject Data Engineering with Python as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 4 first important short question is: what are the advantages of using Pandas for data analysis? Advantages of using Pandas for data analysis. Pandas is a powerful Python library that makes working with data easy and fast. It is widely used for data analysis because it provides special data structures like series, 1D data and data frame, 2D data. Key advantages. 1. Easy to use. You can quickly load, clean, and analyze data with simple functions. 2. Handles different data formats, supports CSV, Excel, SQL, JSON, etc. 3. Fast data operations, sorting, filtering, and grouping data is much faster than plain Python. 4. Missing data handling. Pandas makes it easy to detect and fill missing values. 5. Built-in visualization. You can make quick graphs using .plot. 6. Integration. Works well with NumPy, Matplotlib, and other libraries. Example. Import Pandas as PD. Data is equal to name, Asha, Ravi, marks, 85, 90. df is equal to pd.dataframe, data. Print df. This creates a clean table of names and marks in seconds. Memory trick. Pandas is equal to Excel in Python, easy, fast, and powerful. Next important short question is: 2. Define data frame and series in Pandas. Data frame and series in Pandas. In Pandas, series and data frame are two main data structures that make handling data easy. 1. Series. A series is like a single column of data with labels, index. Think of it as a list with names. Example. Import Pandas as PD. S is equal to pd.series, 10, 20, 30, index is equal to A, B, C. Prints. Output. A 10. B 20. C 30. 2. Data frame. A data frame is like an Excel sheet or a table with rows and columns. It can hold multiple series together. Example. Data is equal to name, Asha, Ravi, marks, 85, 90. df is equal to pd.dataframe, data. Print df. Output. Name marks. 0 Asha 85. 1 Ravi 90. Memory tip. Series is equal to 1D data like a column. Data frame is equal to 2D data like a table. Next important short question is: 3. What is the use of describe and info functions in Pandas? Describe and info functions in Pandas. In Pandas, describe and info are two very useful functions to quickly understand your data. 1. Describe. It gives summary statistics of numeric columns in your data frame. It shows count, mean, min, max, standard deviation, and quartiles. Example. Import Pandas as PD. Data is equal to marks, 85, 90, 78, 92. df is equal to pd.dataframe, data. Print df.describe. Output. Marks. Count 4.000. Mean 86.250. STD 6.291. Min 78.000. 2. Info. It gives a quick overview of data structure, number of rows, columns, data types, and memory usage. Example. Print df.info. Output. Class pandas.core.frame.dataframe. Range index 4 entries 0 to 3. Data columns total 1 columns marks int 64. Memory tip. Describe is equal to numerical summary. Info is equal to structure summary. Next important short question is 4. List out differences between MySQL and MongoDB. Differences between MySQL and MongoDB. Feature MySQL MongoDB. Type relational database, RDBMS, NoSQL database, document-based. Data storage stores data in tables, rows and calls, stores data in JSON-like documents. Schema fixed schema, structure must be defined flexible schema, fields can vary. Query language uses SQL, structured query language uses Mongo query language, MQL. Data relations supports joins for related tables embeds related data inside documents. Speed best for structured data and transactions best for unstructured big data. Example. In MySQL, student data is stored in a table with fixed columns, name, age. In MongoDB, student data is stored as a flexible document. Name Ali, age 20, skills Python, SQL. Memory tip. MySQL is equal to tables and SQL, best for structured data. MongoDB is equal to documents and JSON, best for flexible data. Next important short question is 5. Write a short note on plotting data directly using Pandas. Plotting data directly using Pandas. Pandas makes data visualization quick and easy by allowing you to create plots directly from series and data frames without writing much code. It uses the Matplotlib library internally. You can use the .plot function to make line, bar, histogram, and other charts. This is helpful for understanding trends, comparisons, and patterns in your data quickly. Example. Import Pandas as PD. Data is equal to month, Jan, Feb, Mar, sales, 100, 150, 200. df is equal to pd.dataframe, data. df.plot, x is equal to month, y is equal to sales, kind is equal to bar, title is equal to monthly sales. This code creates a bar chart of sales by month. Why it's useful? Easy visualization directly from data tables. Helps in quick data analysis for students, researchers, and engineers. No need to manually write long plotting code. Memory tip. Just remember. Data frame.plot graph. Next unit 4. Top 5 long questions. First important long question is: explain the process of setting up and using a MySQL database in Python. 1. Prerequisites. MySQL server installed and running on your computer or a remote server. A MySQL user and password. Example, user is equal to root, password is equal to mypwd. Install Python package, pick one. Pip install MySQL connector Python. Hash or for SQL Alchemy plus pymysql plus Pandas. Pip install pymysql alchemy Pandas. 2. Connect MySQL, create DB. Import mysql.connector. Con is equal to mysql.connector.connect. Host is equal to localhost. User is equal to root. Password is equal to mypwd. Cursor is equal to con.cursor. Cursor.execute, create database if not exists sampled. Con.commit. Cursor.close. Con.close. 3. Create a table and insert data. Con is equal to mysql.connector.connect, host is equal to localhost, user is equal to root, password is equal to mypwd, database is equal to sample. Cur is equal to con.cursor. Cur.execute. Create table if not exists students. ID int auto underscore increment primary key. Name varchar 100. Marks int. Hash insert rows. Cur.execute insert into students name marks values %s asha 85. Cur.execute many insert into students name marks values %s Ravi 90 Meera 78. Con.commit. Cur.close. Con.close. 4. Read data from MySQL, simple query. Con is equal to mysql.connector.connect, host is equal to localhost, user is equal to root, password is equal to mypwd, database is equal to sample. Cur is equal to con.cursor. Cur.execute, select ID, name, marks from students. For row in cur.fetchAll. Print row. Cur.close. Con.close. 5. Use Pandas to read SQL, great for data analysis and plotting. Import Pandas as PD. From Sclalchemy import create underscore engine. Engine is equal to create underscore engine. MySQL plus pym MySQL root mypwd at localhost sample. Df is equal to pd.read underscore SQL. Select asterisk from students engine. Print df. Hash quick plot. df.plot kind is equal to bar, x is equal to name, y is equal to marks, title is equal to student marks. 6. Good practices. Use parameterized queries, shown above, to avoid SQL injection. Close connections or use with connection pools. For production, use environment variables for credentials and use a dedicated DB user. Memory tip. Think of Python as the delivery boy and MySQL as the storehouse. Python asks queries, MySQL returns items, rows, and Pandas helps you display or plot them. Next important long question is: 2. Discuss MongoDB and its advantages over relational databases. What is MongoDB? MongoDB is a NoSQL, not only SQL, database that stores data in a flexible, JSON-like format called documents. Instead of tables and rows, as in relational databases like MySQL, MongoDB uses collections and documents. Each document is like a mini JSON file containing key-value pairs, arrays, and even nested data. Example of a student record in MongoDB. Name Asha. Age 20. Subjects Math, Science. Marks Math 90, Science 85. Here, all details are stored together, unlike in MySQL where data would be split across tables. Hammer and wrench key advantages of MongoDB over relational databases. 1. Flexible schema. MongoDB doesn't require a fixed table structure. You can add new fields anytime without changing the entire database. Example, you can add hobbies reading to a document without affecting others. 2. Faster for big, unstructured data. Ideal for real-world data, social media posts, sensor data, logs, where every record may have different fields. In MySQL, altering table structure is slow. 3. Scalability. MongoDB scales horizontally easily by sharding, splitting data across multiple servers. Relational DBs often struggle to scale this way. 4. Easy to store complex data. You can store arrays, objects, or nested data directly in a single document. In relational DBs, This would require multiple tables and joins. 5. JSON-like data makes integration easy. MongoDB documents look like JSON, so integrating with Python, JavaScript, or web apps is smooth. When to use MongoDB? Real-time analytics, IoT applications, social media apps, e-commerce product catalogs, products with different attributes. Memory tip. Think of MongoDB as a cupboard with labeled folders, collections, holding different files, documents, while MySQL is like a rigid table where every row must match the same columns. Next important long question is 3. Explain Pandas data structures, series and data frame with examples. Introduction. Pandas is a powerful Python library for data analysis. It mainly provides two data structures. 1. Series, for one-dimensional data, like a single column. 2. Data frame, for two-dimensional data, like a table. These structures make data handling easy, fast, and more powerful than regular Python lists or dictionaries. 1. Pandas series. A series is a one-dimensional array with labels, called an index. It is like a single column in Excel. Example. Import pandas as PD. S is equal to pd.series, 10, 20, 30, index is equal to math, science, English. Prints. Output. Math 10. Science 20. English 30. Here, labels, math, science, make data easy to access. Print S, math, number 10. 2. Pandas data frame. A data frame is a 2D table with rows and columns. It's like a spreadsheet or SQL table. Example. Data is equal to name, Asha, Ravi, marks, 85, 90. df is equal to pd.dataframe, data. Print df. Output. Name marks. 0 Asha 85. 1 Ravi 90. We can access a column easily. Print df name. Why use pandas structures? Easy indexing and selection. Built-in methods for statistics, mean, sum, count. Can handle large datasets. Works well with CSV, Excel, SQL databases. Quick memory tip. Series is equal to 1D, like a single column. Data frame is equal to 2D, like a table with rows and columns. So, think of series as a single book list and data frame as an entire library catalog. Next important long question is 4. Describe how to handle missing data, reshape data, and combine datasets using pandas. Handling missing data, reshaping data, and combining datasets in pandas. Pandas makes it easy to clean, reshape, and combine data. These features are very important in data engineering because real-world data often comes with missing values and needs organizing. 1. Handling missing data. Missing data appears as nan in pandas. Common methods. Groupna removes rows or columns with missing values. Fillna, value replaces missing values with a given value. Example. Import pandas as PD. Data is equal to name, Asha, Ravi, none, marks, 85, none, 90. df is equal to pd.dataframe, data. df is equal to df.fillna, 0, hash replace nan with 0. 2. Reshaping data. Reshaping helps organize data in a different structure. Pivot, reshape data based on column values. Melt, opposite of pivot, makes columns into rows. Example. df is equal to pd.dataframe, name Asha, Ravi, subject math, science. Marks 85,90. Reshaped is equal to df.pivot, index is equal to name, columns is equal to subject, values is equal to marks. 3. Combining datasets. We often merge multiple files or tables into one. Concat joins data frames vertically or horizontally. Merge combines based on common columns, like SQL join. Join adds columns from one data frame to another. Example: df1 is equal to pd.dataframe, id1, to name Asha, Ravi. df2 is equal to pd.dataframe, id1, to marks 85,90. Combined is equal to pd.merge, df1, df2, on is equal to id. Quick recap. Task function. Handle missing data dropna, fillna. Reshape data pivot, melt. Combine datasets concat, merge. Memory tip. Think of missing data as empty seats, reshaping as rearranging furniture, and combining as joining two tables together in a restaurant. Next important long question is: 5. Explain different types of plots in Matplotlib, pyplot, and demonstrate customization with examples. Different types of plots in Matplotlib, pyplot, with customization. Matplotlib is a powerful Python library for making visualizations. The pyplot module is most commonly used to create charts and graphs. It makes data easier to understand by turning numbers into visuals. Common types of plots. 1. Line plot. Shows trends over time or continuous data. 2. Import matplotlib.py plot as plt. 3. X is equal to 1, 2, 3, 4. 4. Y is equal to 2, 4, 6, 8. 5. plt.plot, x, y, color is equal to green, marker is equal to O, line style is equal to dash dash. 6. plt.title, line plot. 7. plt.show. 2. Bar chart. Compares categories or groups. 3. Categories is equal to math, science, English. 4. Marks is equal to 85, 90, 80. 5. plt.bar, categories, marks, color is equal to orange. 6. plt.title, bar chart. 7. plt.show. 3. Histogram. Shows frequency distribution of data. 4. Data is equal to 10, 20, 20, 30, 30, 30, 40. 5. plt. Hist. Data, bins is equal to 4, color is equal to blue, edge color is equal to black. 6. plt.title, histogram. 7. plt.show. 4. Scatter plot. Displays relationships between two variables. 5. X is equal to 5, 7, 8, 7, 6, 9, 5, 4. 6. Y is equal to 99, 86, 87, 88, 186, 103, 87. 7. plt.scatter, x, y, color is equal to red. 8. plt.title, scatter plot. 9. plt.show. 5. Pie chart. Shows percentage or proportion. 6. Subjects is equal to math, science, English. 7. Sizes is equal to 30, 40, 30. 8. plt.pie, sizes, labels is equal to subjects, autopt is equal to %1.1f%, start angle is equal to 90. 9. plt.title, pie chart. 10. plt.show. Customization options. Color, line style, marker for style. X-label, Y-label, title, for labels. Legend, to show labels for multiple plots. Grid, true, to add grids for clarity. Memory tip. Think of line for trends, bar for comparison, histogram for distribution, scatter for relation, pi for proportion.